To start with the basic thing, what is a Cassandra? Cassandra, Apache Cassandra is an open source, distributed, decentralized, scalable, highly available, fault tolerant, tunable, consistent, column oriented database. So we can see here, there are a lot of things that is there in the Cassandra. Now we will try to figure this out. We'll try to break this part into smaller things. We'll break this part into smaller things, this complete definition, and then we'll try to understand what exactly is Cassandra. So first of all, what is a Cassandra? Cassandra is basically a database, right? It's a distributed database. Now, what exactly is a distributed database here? So let me open Paint here. Distributed database means that our software is running on multiple machines. That's the meaning of distributed database. So say suppose these are the three machines, machine number 1, machine number 2, then machine number 3. So we'll be having Cassandra running here also. I'm saying CS is the Cassandra running on machine 1 also. Cassandra is running on machine 2 also. And Cassandra is running on machine 3 also. So, and these Cassandra, they talk to each other. So Cassandra running on machine 1 talks to Cassandra running on machine 2. Similarly, Cassandra running on machine 1 talks to Cassandra running on machine 3. And the same is the case for 2 and 3, and also with 3 and 1 and 2. So when we say a distributed database, we mean to say is that our Cassandra or the database is not running on a single machine, it's running on the multiple machines. That's the meaning of distributed here. Now coming back on the definition, second point is an open source distributed. It's an open source, by the way. Open source means that yes, you don't have, it's an open source available in the market. It's currently acquired by Apache, and Apache has a by the way very strong documentation team, documentation also, as well as a developers team also, wherein they produce latest versions quite often, and also they're fixing bugs in Cassandra quite often. So we'll come on this part, the data part, but it depends in Cassandra. Like first of all, there is something known as a replication factor in Cassandra. We'll talk about the replication factor later, but the replication factor tells us on how many nodes you want to have your data present. What does this mean is, so suppose we have an employee table. We are creating a single row for an employee. Maybe employee name is ABC. Then we can tell this Cassandra whether I want to store this ABC on node 1, or whether I want to store this ABC on node 2, or whether I want to store this ABC record on node 3. We can also tell Cassandra whether we want to store this data on 1 and 2, or 1 and 3, or something. We want to store this data ABC on all the 3 nodes. So the first thing to your question is, there is something known as a replication factor that will decide my data is going to store on how many nodes, right? So if it is stored on node 1 and node 3, then that means the data has to be same on both the 2 nodes, right? So then it comes under the consistency part, and how Cassandra maintains that consistency between the nodes, right? That's altogether a different thing. And then we will come to know, when we talk about the consistency, what is the meaning of consistency, and how Cassandra maintains this consistency. So if we have decided that my data to get present on 2 nodes, and by the way, this is configurable in Cassandra, then in that case, you will be having same data on these 2 nodes, right? So we're talking about, we are here on the open source distributed. Now there is something known as decentralized database here. Now, what is the meaning of decentralized database? Decentralized database means is Cassandra does not follow the master-slave architecture, right? Cassandra follows peer-to-peer architecture. What does that mean, peer-to-peer? Peer-to-peer means that each and every node is capable enough to do the task of other node. That means if we have a node 1 is capable enough to do the task of node 2 and node 3, right? So they are following a peer-to-peer architecture, wherein if say suppose one of the node goes down, say suppose node 1 goes down here, this node is not up, but still we can get the data from node 2. We can get the data from node 3, because as I said, we can tell Cassandra if my data is present on all the 3 nodes. We can afford one of the node goes down, we can still get the data from node 2. If node 2 goes down, we can still get the data from node 3. So that's the point of decentralization here. We don't have a central point of storing the data. We are storing the data in nodes depending upon the replication factor. That replication factor we'll see later, but they are following a peer-to-peer architecture here. Then comes under elastically scalable. Now, what is the meaning of scalability here? Scalability means, if there is a huge amount of data, there is a huge inflow of data coming to the system, and how my system is, how I can scale my system in such a way that I can handle this huge amount of data coming here. Now, suppose, consider my laptop. My laptop is having some configuration. When I say configuration, I'm talking about the RAM and the hard disk. Say my laptop is having 6 GB of RAM and then 500 GB of hard disk, right? And I'm storing the data. Also, I'm processing the data in memory. At one point of time, if the data coming to my laptop is so huge that I cannot store the data on the hard disk, right? So I know whatever configurations I have, they have been now consumed. So what option do I have to handle this huge amount of data? One option is I will increase the configuration in my laptop. Probably I will try to add more RAM, and also I will try to add more hard disk. So for the time being, I can handle the huge amount of data. But then there may be still a possibility in future that this problem can again come, because we cannot control the amount of data we are getting from the internet, from the source, right? That we don't have control on the amount of data. So if we are increasing the configuration on a single machine, then it is known as vertical scaling. So what we are talking about currently is a vertical scaling. So if we are increasing the configuration of a single machine, maybe in terms of whatever resource it is, in terms of RAM, in terms of caching, in terms of hard disk, then we say it is a vertical scaling. But vertical scaling has its own limitation. We cannot keep on increasing the configuration of a system. There has to be some limit, right? We cannot keep on endlessly increasing the configuration. Now, the other option is known as horizontal scaling. Now, what exactly is a horizontal scaling is, let me open a new paint here. Say, suppose this is a single machine that is running initially, and this was handling some, huge amount of data is coming to this machine now, right? Now, assume earlier, this machine was storing close to 1 lakh records, or it was, handling 1 lakh records. Now we figured out that as soon as the amount of data is getting more than 1 lakh, that this machine is not able to handle the huge amount of data. So what I will do is I will simply put one more node here. This was my earlier node, node 1. This is my new node, node 2. I will simply create a new setup. When I say new setup, I'm talking about first the machine has to be there, and then I say that this new node or the software running on this new node will connect to the existing node that is already there and take some of the data from node 1. And then, it says that, okay, this much amount of data is now handled by me. In this case, say if it is a 1 lakh records, maybe the node 2 will say, okay, I will handle maybe 45,000 records. 45,000 records I will handle. 45,000 is handled by the node 2. That means 45,000 records has been now removed from node 1. So node 1 has the capacity of 55,000. So this is 55,000 on node 1 and 45,000 on node 2. So what we have done is earlier node 1 was having 1 lakh records, and we figured out that, okay, node 1 cannot handle more than 1 lakh. So we just started new machine. It connects to the node 1 and get some of the data. And 45,000 records has been transferred from node 1 to node 2, and only 55,000 are remaining on node 1. Now what will happen is node 1 and node 2, they have the same capacity. Now we can handle 45,000 records also on node 1. We can also handle 55,000 more records on node 2. Now if the situation again arises like 1 lakh record on node 1, 1 lakh record on node 2 also, we just need to create one more node here, and it will automatically, it will connect to one of the nodes or maybe both the nodes. It can happen. So it will take some of the records from them. So this type of solution that we are talking about is known as horizontal scaling, wherein we just need to create new nodes, and it will connect to the existing nodes and get the data, and the data that has taken will be deleted from the previous nodes that are there in the cluster. Now imagine that same case. What will happen here is that initially we have node 1, so we have a Cassandra running here, CS is running here. As soon as we figured out that CS can handle only, cannot handle more than 1 lakh record, that's the capacity. So what we will do is that we will start a new node, right? So we will start a new node. We will again say there is one more Cassandra instance running, and we just need to mention the IP of the node 1. That's it. So as soon as we mention the IP of the node 1, so as soon as node 2, we will start node 2 and the Cassandra is running on node 2, it will connect to the existing nodes, and then it will take the data automatically. So there is no manual intervention here. So it is automatically done internally how much data it has to take from the node 1, right? So this is done very, these steps are very easy in Cassandra. So you just need to start the Cassandra instance on other node, tell the IP of the existing nodes, and it will connect to the existing node, get the data from there. As simple as that. So this is known as horizontal scaling. So horizontal scaling is one of the features in Cassandra. That's a powerful feature, because in case of other databases like Oracle and all, you have to do a lot of manual things. But here it is a bit easy kind of job. You don't need to do anything. In fact, we will see this kind of demo also in our lecture. So just need to start one instance. It takes the data and stores the data on its own local storage. So that's the meaning of high scalable. Now coming back on the point, highly available. Now highly available means is that, first of all, what is the meaning of availability? Availability meaning is that if we have an n node cluster, right, and if we have a single node running, we should still get the response back. So availability here means that since in Cassandra we can say we can store the data on all the nodes, on many of the nodes. So if one of the node goes down, we can still get the data from the other nodes. So if my data, for example, if we have a 3-node cluster, my data is present on node 1, node 2, node 3. And then if node 1 goes down, we can still get the data from node 2. If node 2 is down, we can still get the data from node 3. So that's the meaning of availability here. So it can afford the failures depending upon the replication factor that we have set, by the way. So the one thing that is important here is replication factor with respect to the availability. So if we are saying our data is present only on the 2 nodes, maybe on node 1 and node 2, so that means we can only afford 2 nodes to go down, because right. So in this case, yeah, not exactly the 2 node, by the way. If my data is only present on the node 1 and node 3, right? So in this case, I can only afford 1 node to go down, right? If 2 nodes like 1 and 3 goes down, then I can never get that data back, because I know my data was present only on 1 and 3. So depending upon the replication factor that we have set, we can decide the availability here for the system. Then comes the next thing is fault tolerant. Now, what is the meaning of fault here, first of all? Then we will see what is the meaning of fault tolerant. Fault means that if we have a distributed database, if we have a distributed system, so they are connected with each other through some link, probably any network links are there. Now, when I say there is a fault, there is a problem between the communication of the 2 machines, say this is the fault. That means machine 1 is not able to communicate to machine 2. So that's the meaning of fault here. Now, what is the meaning of fault tolerant? If this is a situation arising wherein machine 1 is not able to communicate to machine 2, and then we should say that the whole system is not down. That is the meaning of fault tolerant. If the link between any two of the machines are down, that does not mean that the cluster is down. So these two machines should run independently on each other. They should not be dependent on each other. So as soon as the link gets again, comes back, they should be able to sync up the data that they have messed up. So this is automatically done in Cassandra part. So that's the meaning of fault tolerant. Now, other part is tunable consistent. Now, first of all, what is the consistency here? Consistency means, yeah. So we are talking about consistency here. Consistency means is if we have a two node cluster, for example, we have a two node cluster, node 1 and node 2. If we are writing the data on node 1, we are writing the data on node 1. So this is the write operation. And then we are reading the data from node 2. If we are writing the data on node 1 and reading the data from node 2, then we should get the latest write that has been written on node 1. That's the meaning of consistent. So data has to be consistent across all the nodes. If the value has been written on one of the nodes, then the same value should I get from the other node. In Cassandra, because this is a distributed nature, right? So in case of Cassandra, there is something known as tunable consistency. Tunable means we have to take this consistency part later in deep, but then at this point of time, what I can say is tunable consistency means I can tell my Cassandra that whenever I need to do a read operation, for example, do I need to consult all the nodes for the read? This is one kind of consistency. If I have a 3-node cluster, node 1, node 2, node 3, and if I can connect to any one of the nodes, the client can connect to any one of the nodes. And then we can say in our commands that we are firing on the Cassandra, okay, give me the data and consult all the 3 nodes. And if all the 3 nodes have the same data, then and only then return me the data back. So that is known as something very strict consistency. This is like if the data is present on all the 3 nodes and they are the same data, then and only then give me the data back, right? The second could be, okay, if we see the data is present on the 3 nodes, but I can say, give me the data from maybe from 2 nodes, any 2 nodes. And if you feel that these 2 nodes are having the same data, then you give me the data back. You don't need to consult, wait for the third node. So this is a bit less strict, right? You are not checking all the nodes here. You're checking 2 nodes. Similarly, there is something known as quorum. Quorum is one of the terminologies that we use in Cassandra. Quorum is mostly, say suppose we have a replication factor of 10. That means what we want here is my data is present on 10 nodes. And if we say my quorum of nodes is whatever replication factor we have divided by 2 plus 1. That is, in our case, it is 10 by 2 plus 1. That is 5 plus 1, 6. So here what we are saying, if we are getting the data same from 6 nodes, out of 10 nodes, you should send me the data back. So these are the consistency levels that we can specify when we do a write operation or a read operation. And then the last is column-oriented database. Now, column-oriented database means what? When we say column-oriented database, we are talking about NoSQL. First of all, Cassandra is a NoSQL database. Now, what exactly is a NoSQL database? NoSQL databases are the databases which does not follow, the pattern of storage similar to what we have in the RDBMS, relation databases, right? So in case of Cassandra, the pattern it follows to store the data is known as columns, right? So for example, if I say I have created an employee table, let me open this. Yep. Say suppose I have created an employee table and I'm saying the field I have in employee is employee name, right? And then employee ID and then employee age. Suppose these are the three fields we are storing in our table. The way Cassandra stores this, and now, for example, let's take two examples here. Say the first record I'm storing for Rohan, and then the employee ID is say 123, and the age is say 24. This is the first example. Let's say we are storing the other example as Rahul, say, and then 34, and then the age is 28. Now, how exactly this is stored at the backend or internal storage of Cassandra is for the record, first record Rohan, there would be stored first the key. This is the key, or you can. So as I said, like this is a record we are going to store, and how internally this will be converted is for this data Rohan, there will be a column created in the backend. For that column, the name would be employee name and the value will be Rohan here. Similarly, for the next employee ID field, there will be again one more column getting created and the name would be employee ID and the value in this column would be 123. Similarly, we will be having one more column getting created for the first row. And here we have the name as employee age and then the value would be 24. So this is for the first record. So, and there are some other fields also in this column, but as of now, we don't talk about that. We are talking about what is exactly a column-oriented database. Similarly, for the next record, we'll be again having the name getting stored here, employee name, and the value is Rahul. Again, the column is, this is for the second column. The name is again the employee ID and the value is 234. And same is the case for the last one. Name is employee age and the value is 28. This is how internally Cassandra creates a column that is an internal structure and then persists that column on its local storage. We have to see this thing in depth when we talk about, more about the internals of Cassandra. As of now, because we are just talking about the definition of Cassandra, so the last thing is a column-oriented database. So it stores the data in this format, the key value pair, the name value pair for each and every column. So that's all the features of Apache Cassandra. Let's see how does a Cassandra look like, by the way. So what I have done is I have created a cluster on my local machine. So I will start the Cassandra and then we will see how does a Cassandra look like, right? So currently okay, let me go to my directory first. So we are using Cassandra 3.5 version for this demo, and in case all the demos that I'm going to show you, right? So here you can see I have created. So whenever first of all, let's go to the basic things here. Here learning. Yeah. So as soon as you download the Cassandra from the internet, what you can see is this installation here. So this is the bin folder of, or this is the main folder of Cassandra. In this folder, what you can see is these are all the, the folders that are present in the Cassandra. So the bin folder is having all the executables that is required. Not all the executables are required, but then some of the executables are used for starting the Cassandra. some of the executables here are used, to come to ask some data from the Cassandra, and some of the executables are used to, to send commands to the Cassandra. So this is a bin folder for that. Then we have this conf folder wherein we have the configuration for the Cassandra. So there is this particular file, cassandra.yml. That's a very important file. Whatever configuration we put in Cassandra has to be in this file. So this is a very, very important file. So we'll see this file also, by the way. So, and then there are other things also in this configuration folder. And then there are, the other things that is important is the lib folder that has all the jar files, because this is a Java process. So it has all the jar files here in this lib folder. So this is how it looks like when you extract the Cassandra folder. Now, in our case, what I have done is I have created a cluster 3.5 here, and I have created 3 nodes here. So you can imagine these 3 nodes are, for each node is running on a new machine, because this is a single machine. So I have created different folders for that. In case of, in real world examples or in the real world setup, this node 1 will be running on one machine. This node 2 would be on some other machine, and node 3 would be on some other machine. So what we have here in node 1 is, and this is not related to these nodes at all. So if we go to node 1, what we have is the same setup that I have shown you. We have Apache Cassandra 3.5 here. Then we see all the things here. The similar things, bin, conf, everything here. Similarly, we have node 2 here. It has all the same installation. And node 3 here also. It has all the same installation. Everything is here also same. The only thing is they know each other IPs also. We have to tell, in these things, so what is the cluster name and all. Then we'll probably see when we take the course further. But then as of now, the thing is I'm showing you how does a Cassandra look like, right? So this is a Cassandra on the file system. Now we'll see how we start the Cassandra and how we can see whether the Cassandra is running or not. So what I'm going to do is I will go back in each one of the folders. So we are currently going in node 1. I'm going in Apache Cassandra 3.5. Now I'm going in bin. What I will do here is that I will say this is my node 1, right? So node 1 has been, this window has been renamed to node 1. Similarly, I will create to node 2. I will go to node 2. So I'm going in the node 2 window. So this is my node 2. Then Apache Cassandra, then bin again. Then I will say, okay, this is my node 2. I will start one more session and I will say this is my node 3. Okay, so I will go in the node 3 folder. Then I will start 2 more sessions here. Maybe only one is required as of now. Okay, I'm going in the node 1. Right. So this is for SQL SH. Now, what is the SQL SH? We will come to know. But as of now, there is one window for SQL SH. Maybe we can start one more window, and this is for node tool. What is this node tool? We'll also come to know. So total, we have started 5 windows. Node 1, node 2, node 3. Then we have one session for SQL SH and one window for node tool. So let's go back here and see how to start the Cassandra. To start the Cassandra, we have a cassandra.bat file here in the bin. And if you say -f, that means we are running this Cassandra. We are starting now the Cassandra on node 1, and we are starting it with -1. That means the process, you can see it on the command itself, right? So we have started this Cassandra on node 1. Now, let's go back to the last window, that is a node tool. Now, what exactly is a node tool? Node tool is a utility that is provided by the Cassandra, and here by this utility you can ask Cassandra certain things like what all nodes are there in the cluster, what is the ring topology, what is the tokens and all. So you can ask this by this node tool command. So we have this node tool utility in this bin for node tool. So we just started node 1 and we could see that we have seen there is one node that has been created. Now let's say we go to node 2 and we say again cassandra.bat -f. Now we are starting Cassandra on node 2. Okay. Now let's say again go back to the node tool command and say what is the status of the cluster. Now we can see that the node 2 has also joined the cluster here. So node tool is also in the status command and is normal, up and normal. So that was for the node 2. Let's go back to the node 3. Now, okay. So let's see again the node tool command here. Now we can see that the node 3 has also joined the cluster. Now the status is the command that is telling me what all are there in the cluster. By the way, what is the meaning of cluster? What is the meaning of node? What is the meaning of instance? We have to see that in so currently you can see this. I was just trying to show you how does a Cassandra look like. So these are the 3 different nodes, and then there is a node tool command by which you can get the information about the cluster and all. There is also one utility known as SQL-sh. Now, SQL-sh is basically used to do DML operations or the read operation also from the Cassandra. Like if you know a database like Oracle, right? So we have SQL Plus as a client in Oracle, right? So that connects to the Oracle database, and then you fire the commands on database. Similarly, we have the SQL-sh utility provided by the Cassandra. So here we are connected to the cluster, Cassandra cluster. So here we are connected to the node 1 here, node 1. So if you see that, this is telling me that we are connected to the node 1. So if you say describe cluster, it's telling me that my cluster is having, so this is a way by which you can fire the commands on the node. So there is a command known as describe cluster. So this will give me the information about what is the cluster name, first of all. So this is a test cluster. And then we have a partitioner. What is a partitioner? Used in this cluster. So these are the utilities as of now. Now let's come back to the further things. So that was about Apache Cassandra. How does it look like? Then come back to this is the same thing. Yep. Okay. Now, first of all, let's say there is something known as a key space. Now we are getting into more, internal, in more into the Cassandra part now. What is a key space? The first thing we are learning is a key space now. Key space is basically a logical, the kind of is a logical, entity in Cassandra, and the way we have schema in Oracle is the same way we have key space in Cassandra. So you can consider this key space as an outer container, right? Inside this key space, you can create the tables, but these key spaces normally has to be bit logical, and normally the way we use these key spaces are with respect to the business domains. For example, if we say we have a company, right, that company is storing the data for HR department. Maybe one of the HR is one of the departments here. Then we have some engineering team is one of the departments. So probably what I will do here is that I will create, one key space for HR and one key space for engineering, right? And maybe I will have one key space for the products that our company is dealing with. The key space is the outer entity wherein you can create the tables. So now if say suppose we have 3 products, right, that our company is maybe exporting in the market, then we will do inside this key space product, I will say create a table, create a table for product 1, similarly create a table for product 2, similarly create a table for product 3. So first thing we need to know is we need to create a key space that is an outer container. And then inside this key space, we are creating the tables. Now, product 1, product 2, product 3 are the tables here, and product is the key space. That's the meaning of key space. Now, let's say we are creating a key space. How do we create a key space, by the way? If you see the above example, create key space is the command. Then this is a key space name. Here we are creating a key space known as learning, and then there is some other parameters to it. We will see these parameters soon, but as of now, we will just see a command. How does it look like, and how it gets fired on the, on the cluster. So let's go back to the SQL SH. So we are connected to the node 1. We'll simply create a key space with learning. Now, whenever we want to, get the data from any table, we have to either say, if we want to get a data from product 1, we can simply say select star from product 1. This is the one option. The second option is we can simply say select star from product, that is this key space dot product 1, right? So always if we are in this key space, then we can directly write select star from product 1. But if we are not in this key space, then we have to say it select star from product dot product 1. Now to get into a key space, okay, before then that, let's say we have created this key space. How we can see the definition of this key space? So we can simply say describe learning. Now, as soon as I did describe learning, I can see the command that I have used for creating a key space here. Although it has added some more things here, I haven't added this durable rights here, but that has been because the data we are getting is the metadata we are getting for this key space. So this is a describe command. Now let's say I want to get into a key space. So we have to use command for that. We are saying, okay, now I'm in the key space learning here. Similarly, if I have a key space product, I simply say use product. And then if I do select star from product 1, then I can simply say, okay, I can simply see the contents of product 1. So key space is our outer container. Let's say we create a table also here. Let's say, let's go back to creating a simple table here. Don't focus much on the syntax part, primary keys and all, but then this is just to show you how to create a table and how to insert a data in that table. Oh, if I do select star from employee, I can see this data here that I have inserted. Similarly, if I do select star from learning.employee, I can still see that data back because now I'm using with a key space. Now, what has been done at the backend? The first thing you will see as soon as we create a key space, right? And whenever you create a first table in that, if you see at the backend, there is something that has been, what changes it has done on the backend. So we are on node 1. We go to the data folder, and then there is a folder. This folder is the column families, commit log, hints, and all are configurable. You can configure or you can specify these folders in your cassandra.yml file, right? So we will see this also, but then before that, we are just focusing on how what changes it has done at the backend of the Cassandra. So we just created this key space learning, and then we created this employee table. So if you go back to the column families, by the way, column families is one of the names that we used to have earlier, for the tables, right? But now we are saying more into tables and all. Earlier, when Cassandra was starting, maybe from version 0.7.2, 1.4, we used to have more column families. We used to use the terminology for column families. Now, mostly we are using directly in our tables, similar to what we have in the Oracle database. So what it has done is it has created this key space folder. As soon as you have created a key space, the first thing it has done is it has created this key space here. Learning is a folder. And then when you created this table also, employee, you can see this employee table here, one more folder for that. And this particular record that we have inserted is still in the memory, and these records will be stored somewhere here. When these records will get persist on the disk, it will be stored somewhere here in this location only. So currently it is in the memory. That's why I could not see any of the files here. So this thing we will see later when we talk about internals of Cassandra, the architecture of Cassandra, how the things are happening, how the writes are being written in the Cassandra. But for the time being, what we are seeing is there is a folder for the key space. For each and every key space, you can see a folder at the backend. In that folder, you can, for each and every table you create, there's a folder at the backend. And then whatever data you store, if the data is flushed on the disk, then you can see those files here also. Now let's say we go to the node 2. If you see, we have connected to the node 1 here, and we have inserted the data on the node 1. So what has happened on the node 2? The node 2 is also having the same, key space, although you could see some other different structure here, but that's just a configuration part here. We can have the same structure as the node 1. So the important point to understand is for each and every key space, one folder has been created. Then the same employee here. Same is the case for node 3. Learning and then the employee. So these are the things. So that means that whatever data we are inserting, right, it has to be present. Whatever folders, whatever key spaces we are inserting, creating, it is created on a cluster wise here. Whatever tables we are creating, although we have just connected to one of the nodes, but the data or the storage is present on all the 3 nodes, right? So let's see. Okay, before then that, we need to figure out where exactly this 123 has been stored. Is it stored only on node 1? Is it stored on node 2? Is it stored on node 3? Or is it stored on maybe only on 1 and 2, 1 and 3? We'll see this thing later. But currently, we're just saying that there is something known as the key space, and that inside that key space, you are creating a column family. That column family is nothing but the table. And inside the table, you have nothing but a column. So each and every field is represented by a column. That's the meaning of the key space, right? Now, yes. So before that, before understanding further in the key space, we need to understand some of the terminologies that we are using in Cassandra. Let's go back to, yes, we need to understand these terminologies. What is a cluster? What are nodes? And what is a data center, by the way? First of all, what is a node? A node is nothing but, it's representing a single machine. So a physical box, normally we say node, but then when we say node in terms of Cassandra, that means the Cassandra instance that is running on a single machine. So if my laptop is running, I'm having a single Cassandra instance running, I will say this laptop is a node 1, right? So it's representing just a single instance of Cassandra, right? When we say data center, Now the data center is also, one of the facilities that Cassandra is telling me in case of, uh, this data center is a concept that is used for, uh, recovery purposes in case of disaster is there, something, natural disasters are there. So how in case of if there is some natural disaster, so how we can, recover from that. So then we have this concept of data centers in Cassandra. Now, what we have in data center, we can say in Cassandra, that one of the data centers is in US and other data center is in India, for example. Now, if something happens that we could not operate from India, we can still get the data from US. So that's the concept of data center. How to configure the data center, we'll see that later. But data center is, again, as I said, we have it's a logical term again, wherein we say this region is having this data center, this region is having this data center. Now, till now, what we have seen is two parts. One is the nodes, and another one is the data center. If I try to put this thing, this is like, say, suppose we have node 1 here, one Cassandra is running here, then we have node 2, then we have node 3. Similarly, we have node 4, we have node 5, and we have node 6. Right? So we have total 6 machines, 1, 2, 3, 4, 5, 6. Out of 6 machines, say 3 machines are in India and 3 machines are in US. Quite possible, it can happen. So we will say this is one of my data center from India, right? So I will configure, this we have to say in our configuration file. So I will say my node 1, node 2, node 3 belongs to data center in India. Similarly, I will say my node 4, node 5, node 6 belongs to data center US, right? And also there is a replication happening here, right? So it should not be node to node, it should be data center to the data center. So it could be possible, these nodes are talking to each other, right? Node 1 to node 4, node 5, node 6. Each and every node knows the topology of the cluster, by the way. So node 1 knows what all nodes are there in the cluster. So node 1 has the information of 2, 3, 4, 5, and 6. The very important thing here is that in Cassandra, so Cassandra has this provision that if the replication is happen from one data center to other data center, that can happen in asynchronous way also and synchronous way also. And this is configurable depending upon how you do a write operation and a read operation. There's one more benefit of Cassandra, by the way. Now, this is the meaning of data center. This is the meaning of nodes. What is the meaning of cluster here? Cluster is like a superset of all the nodes. That includes all the data centers and all the nodes here. So in this diagram, we have as a cluster. We have created a cluster which has, this is my complete cluster, which has 2 data centers, and each data center is having 3 machines. So this is the complete setup is known as cluster. We can have a setup also wherein we have a single data center, maybe India, and then we only have the 3 nodes, right? So if you see on my local machine, what is there is if you go back to node tool command, you see that there is a single data center 1, that is having all 3 nodes. And that means my machine is having a cluster with single data center, and this data center is having 3 nodes here. And what is the cluster name? The cluster name, you can see it in SQL SH when I did describe cluster. So cluster is test cluster is the name of the cluster here. Now, where we can configure this cluster name, by the way. Now it's time to see the configuration file that I have shown you earlier, but let's move inside this configuration file. So if we go back to our cluster 3.5, or maybe we should go it here. So 3. So we are in node 1. We can see there is a folder Apache Cassandra configuration file, and there is this Cassandra YML file. You see, guys, here test name, cluster name. There's a test cluster. There's the name of the cluster here in node 1. Similarly, if we go to node 2, we go to configuration, we go to Cassandra.yml file, we can see again the cluster name is test cluster here, and the same is for that node 3. Now, this is the first requirement. If you want the nodes to join the same cluster, then they should have the same cluster name. So in our case, it's the test cluster that is there on all the 3 nodes. That's why you can see it, the test cluster here. So that was about the data center, about the nodes and all.